Hi, this is Angela Galloway, and I am doing a quick video for STA220 for Chapter 5. In Chapter 5, we talk about a lot of different ways to use probability, and different formulas we're going to use, but one thing that we see at the end of Chapter 5 is different counting methods. So I had a few examples already listed in some of the other Chapter 5 lecture videos, but this is one specifically talking about how to use combinations, especially in some of those harder examples where you're trying to find combinations when you've got multiple groups inside of groups. And so that's what I'm going to do on this example, is kind of go over combinations and some of the ways you can use it. So combination is a collection without regard to order in which our objects are chosen from n distinct objects without repetition. So mainly what this is saying is that we're looking at how many ways we can choose a certain number of items from a larger group. And in particular combinations, the order doesn't matter. So if I have person A and person B and person C, choosing them as A, B, C is the same as choosing them as C, B, A. So that's what it means with the without regard to order. If it matters who's chosen first or second, then that would be something you would actually use permutations for, which we don't cover in our class, but that is something that you would see in the book in Chapter 5. But so here with the combinations, this is our formula, the NCR. And so the way we say it here is we're going to say N choose R. So from the larger group N, we're going to choose a certain number of items at a time, which we're calling R. You may see it written out like this, and specifically we do see that in the binomial distribution in the formula. The N choose R is written out in that way. Mainly I think it just fits into the formula easier to have it written that way. But then the actual formula is this, where we're using these factorials. And so to be able to do this problem in the calculator, you would have to go to this probability menu here. After you click the math button, you go to the probability menu, and then you would see the factorial there. But right above it is the NCR, which is actually combinations. So that's what we're going to use. You could use the formula, but it seems like since you're going to go to that menu anyway, you might as well just use the combinations, right? That saves us some time. So the example we're going to do here is about a teacher who has a class of 30 students, and she wants to create groups of 5 for them to work on a presentation together. If she randomly chooses the group, how many different groups of 5 could be created? So we need to identify what our total sample size is, which is the N, and then what size groups are we choosing, which we're going to use the R for. So N would be 30, right? We have 30 total students, and we're going to do groups of 5. So 5 is going to be the R. So the way we would write this out is we would have 30 choose 5. Okay, now in the calculator, what that will look like is this. So let me pull up my calculator. And so what I usually do is I'm going to type the N first, which is the 30. Then we're going to go to the math button and over to the probability menu here. And we're going to choose the third one, which is the NCR, and press enter. And then the way my calculator does it is it kind of puts the numbers as subscripts. Yours may not look like that, but it should still get you the same answer. So I've already got the 30 in there. Now I'm going to put in the 5 because that's the size of the groups that we're choosing. And then that's going to give me my answer. Then the next one says, in this class, there are only 5 guys. What is the probability that all 5 of them will be in one group together? So now we're not just looking at how many ways can it happen, but what is the probability that it would happen? So for finding out the probability, we really need to look at how many ways it can happen, right? So the probability of choosing all five of the guys to be in one group, we need to look at the number of ways to choose the 5 guys over the total number of groups, which is what we already found in Part A. So the total number of groups is that 142,506. So we just need to think about how many ways could we put 5 guys into a group of 5. So if order doesn't matter, then all 5 of those guys being in one group together can only happen one way, right? And that's when all 5 of them are in that group of 5. So there's only one way that can happen. And so the probability of this happening is 1 out of 142,506, which if we, divide that out, we get a very small number, right? Less than 1%. So it comes out to 7.017 e to the negative 6, which is another way of just writing scientific notation, like times 10 to the negative 6. Or you could put 5 zeros in front of that 7, so it could be 0.000007017. Either way, a very small probability of that happening just by chance. Okay, so let's do a problem that's still using combinations but has several kind of moving parts to it, which can make it a little more difficult. So here we've got a club, and there are a mixture of AS and AA degree students in it. There are 30 total students in the club. 19 of them are AS and 11 are AA. Only 5 of the members are going to be randomly chosen to attend a state conference. So we want to find the probability of these different scenarios. So the first thing we want to look at is what is the total number of outcomes for this experiment, because that's what we're going to use for our denominator no matter what scenarios we're looking at, choosing 1 or 2 of a certain degree student, whatever we want to know, we still are going to have to know that total number of outcomes. So on this one, we have how many total students? So we've got 30 total students, right? So from the 30, we're going to choose how many? It says we're going to choose 5, right? So 30 choose 5 is our total number of outcomes, right? So 30, and then choose 5, and we get 142,506. And that does happen to be the same total we got on the last problem. That's obviously not always going to happen. I guess when I was making these examples, I just liked the numbers 30 and 5, so I happened to use it twice. But don't let that confuse you. It won't always be 30 and 5. That's just what I happen to do for these examples. So that's going to be our denominator for any of these probabilities that we're trying to figure out. So the first question is, what is the probability that all 5 students chosen are AS degree students? So we've got these 2 groups, right? So we've got our 19 AS students, and then we have the 11 AA students, and we have 30 total. And from those 30 total, we're going to choose 5. So that is what we're working with. We've already figured out how many total ways this can happen, but we want to then find out what's the probability that all 5 of the students chosen are AS degree students. So then we would just be looking at our AS group, right? So how many total AS students are there? So there's 19 total AS students, and we're going to choose 5 of them. And then if we choose all 5 of them, from AS students. We're not going to choose any AA students, right? Because all 5 are going to be AS, so we don't have to worry about the AA. But we can look at how many ways can this happen, right? So we would do 19, and then we would choose 5. And we get 11,628. Now that's how many ways it can happen, right? That's not the probability. A probability is always between 0 and 1. So there's that many ways it can happen. So our probability, the probability of choosing all 5 AS students would be 11,628 divided by 142,506. So we get 0.0816 for our answer there. All right, so that would be the answer for the first part. Now the second part says, what's the probability we would choose 3 AS students and 2 AA students? So now we need to look at how many ways this scenario could happen with the AS students, and also how many ways this can happen. Right, because there's a certain number of ways we could choose 3 AS students, and there's also a certain number of ways we could choose 2 AA students. So the 3 AS students, we're going to do similar to what we just did. We would say there's 19 total AS students, and we're going to choose 3 of them. For the AA students, we're going to say there's 11 of them, and we're going to choose 2 of them. And then if we want to know the total number of ways that those 2 things can happen, that we have 3 AS and 2 AA students, we're going to multiply those values together. Okay? So if I want to do that on the calculator here, you could do it all at once, or you could do it, in 2 separate things. If I do 19, I go to Math, and then the probability menu, and I'm going to choose 3. Right? And then I'm going to do 11, Math, probability, choose 2, right? So there's 969 ways to choose those 3 AS students, 55 ways to choose those 2 AA students. So we would multiply those, and we get 53,295. And so that is the number of ways we can choose 3 AS and 2 AA. So then the probability of choosing 3 AS and 2 AA is 53,295 divided by 142,506. That's still our total number of outcomes when we're choosing 5 people. So let's divide that. We get 0.3740 if we round to 4 decimal places. So about 37% chance that we would get exactly 3 AS students and 2 AA students. So hopefully that'll help kind of as you're working through maybe your Week 7 weekly review, or just looking through some of the homework for Chapter 5. There shouldn't be a lot of problems like this one, because I realize they take a little longer to think about and work through, but there'll probably be at least 1 or 2 that you might have to work with. Okay, so if you have any other questions, feel free to email me at any time at angela.galloway@kctcs.edu, and I'd be happy to help you out. You can also contact any of our math tutors here at Sky CTC. All that tutoring is free. You can contact them using the contact information that I have saved on our Blackboard page under the tutoring information. So thanks for watching this, and I hope that it helped you out.